Let us check convergence and divergence of the series -1 to power n minus 1, n to power negative a third, and starts from 1 goes to infinity. Okay, so we have -1 to power n minus 1. We can rewrite this as the summation of -1 to power n minus 1 divided by the third root of n, and start from 1 goes to infinity. This guy looks familiar to us. This one is alternating series. Recall that. For alternating series, we had a general form of -1 to power n minus 1 bn. And we said that alternating series is convergent if we have two conditions met. First of all, bn is decreasing. And second of all, the limit of bn as n goes to infinity is equal to 0. So let us take a look. My bn is equal to 1 divided by the third root of n. Let us check convergence and divergence of this series by checking these two conditions. First of all, we want to show that bn is decreasing. To show that bn is decreasing, we can use calculus, we can also use algebra, either is fine, and show that the derivative of bn is negative. For simplicity, let's take f of x to be 1 divided by the third root of x, or x to power negative a third. F prime of x is equal to negative a third, x to power negative a third minus 1, which gives you negative a third, x to power negative 4 divided by 3. So f of x can be written as -1 divided by 3 times the third root of x to the 4th. On the interval 1 to infinity, this guy is always positive. Three is also positive, but you have a negative sign, -1 on the numerator. So the whole thing becomes negative. So it means that the derivative is negative. We just showed that f prime is negative. It means that the function is a decreasing function. And since bn is represented by this function, so bn is decreasing. So the first condition is met. bn is decreasing. What about the limit of bn when n goes to infinity? Number 2. Now, we find the limit of bn as n goes to infinity. This is the limit of 1 divided by the third root of n as n goes to infinity. It's indeed equal to 0. So the second condition is met. So since these two conditions are met, our series is a convergent series. So this is your conclusion. Since for our alternating series, the summation of -1 to power n minus 1 times n to power negative a third it satisfies both conditions, this is a convergent series. The next question that we'll be having is this an absolutely convergent series? Question. Is the summation of -1 to power n minus 1 n to power negative a third is absolutely convergent? Well, let's take a look at absolute value. Check the absolute value of the general term. The absolute value of -1 to power n minus 1 n to power negative a third is basically absolute value of n to power negative a third. Or basically you have absolute value of 1 divided by the third root of n, but this quantity is a positive quantity. So you can get rid of the absolute value. This is equal to 1 divided by the third root of n, or 1 divided by n to power a third. Well, remind yourself of P series. Recall that series of the form 1 divided by n to power p is called a P series. We know that by the integral test, this series is convergent when P is more than 1. It is divergent when P is less than equals to 1. Here, P is equal to a third, which is less than 1. So the series is divergent. What's the meaning of that? So the series -1 to power n minus 1 n to power negative a third is not absolutely convergent. In this case, you can call it conditionally convergent. You can say that since the series is convergent, but it is not absolutely convergent, we call it conditionally convergent. So let us recap what we did. We wanted to analyze the behavior of this series. Is this convergent? Is this divergent? The series is -1 to power n minus 1 times n to power negative a third. Remind yourself of alternating series because they have the same pattern. For the alternating series, if Bn is decreasing and the limit of Bn as n goes to infinity is equal to 0, you can say that, hey, the series is a convergent series. Bn is 1 divided by the third root of n, We just showed that the derivative of Bn is negative. It means that our Bn is decreasing. So the first condition is met. We showed that the limit of Bn is equal to 0, so the second condition is met as well. Since both conditions are met, it means that you have a convergence series. The next question that we're having in mind is this series an absolutely convergent series? Well, if we take the absolute value of the general term, you end up with a p-series, which is indeed divergent. Since the absolute value is not convergent, it's not absolutely convergent. So since it's not absolutely convergent, but it is at the same time convergent, we can call it conditionally convergent series.